In this video, let us learn about the types of loads. The beams are used to resist the loads acting on them which are perpendicular to their longitudinal axis as we see here. Based on this, we have three types of loads: point load, uniformly distributed load or we call it as UDL, and uniformly varying load or UVL. Now let's look at the point load. A point load is where the concentration of the entire load is acting at a small point on the beam. The entire effect of the load is concentrated at that point. A sandbag placed at a particular location on the beam is a point load. Then the second type is UDL or uniformly distributed load. It means for the entire span or the entire length of the beam or even a small part of it, the load is uniform. This load has a unit of Newton per millimeter or kilonewton per meter. For example, we can consider sandbags placed on a beam. So all the sandbags are of same size and weight. Hence, they apply the same force throughout the span of beam. This is UDL. All these forces can be replaced by a single equivalent load which is given by a simple formula. Equivalent load is the load acting on the beam multiplied by the span length for which the load is acting. In our example, 2 kilonewton per meter is acting on the beam for a span of 3 meters. Then the equivalent load will be 2 kilonewton per meter multiplied by 3 meters, that is 6 kilonewton point load. The position of this point load will be at the center of the span, that is at the 1.5 meters from their ends. This is UDL. What about UVL? In this case, the rate of change of load is uniform. The load starts off from zero and keeps on increasing until it reaches the highest load intensity. The highest load is given as W Newton per meter. For example, if we have sandbags of different weights but uniformly varying on a beam, then it is a representation of UVL. Even this load can be replaced by an equivalent point load. The magnitude of that is given by the area of triangle formed by UVL. That is half into base into height of a triangle. Base is the span length for which UVL is acting. Height is the maximum load intensity. So we have half into 2 into 2, which is 2 kilonewton. The position of this load will be along the centroid of the triangle. Centroid is nothing but geometrical center of the object. We'll learn about it in our next course. So, the centroid of the triangle is at 2/3 of the base length, or it can be at 1/3 of the base length from the other end. In this case, we consider at a 2/3 of base length. So, the point load of 2 kilonewton will act along the centroid. You will understand these forces when we solve problems in the upcoming section. Now, let's look at the special case of loads, inclined loads. Inclined loads will act on the beam at a certain angle. We can solve this inclined load by converting it into two components, a vertical component and a horizontal component. We assign cos and sin values to these components. Cos theta is always on the side from which the angle is measured. The other side will be sin theta. In our case, the horizontal component is cos theta and vertical component is sin theta. Suppose we have an inclined load where the angle is measured from the other end, then the vertical component would become cos theta and horizontal will become sin theta. These two components of force will be used in equilibrium equations to solve the problem. So far, we have learnt about the types of supports, beams and loads. Now, to solve any problem, we should know the support reactions and moments. We know about support reactions, but what do we know about moment?